very similar to the rest of the syllabus. It's nothing different. The only thing is that any practical that you want to do or anything related to practical, especially in your paper to paper 4 or your syllabus, that's going to come in ATP as well. So your topics, we'll just briefly go over your topics. Your topics are uh, you've got kinetic particle theory. That's all about solids, liquids, and gases. Diffusion, Brownian motion. Uh, you've got mixtures and compounds. You've got separation techniques. You've got experimental chemistry, which is all about how to do experiments in the lab. You've got atomic structure. You've got chemical bonding. PK, this is not the right order in the syllabus as well. I'm just telling you what the topics are in one go. You've got chemical bonding. Then formulas, equations, compounds. That's something that's very, very important. And most of those equations are related to acids, bases, and salts. So in all your chemistry exam, all your chemistry syllabus, most of the difficulty level lies with making equations and balancing equations and understanding equations, how to write equations. There's going to be a lot of things around equations. So making formulas, knowing how to make formulas, knowing how to write equations, balance equations, all of that is really important. Acid basis salts is something that's very, very important as well. Achha, and a lot of these topics are very interconnected. Electrolysis, again, that's very much related to the above two. You've got metals and the reactivity seas. That has a lot to or interconnected with acids, bases, and salts as well. Extraction of metals. Okay, that's a big topic as well. I'm going to underline all the big important topics. You've got moles and stoichiometry. That's mathematical and also very much linked to how to write and balance equations. And so these middle topics are very, very interconnected. They're very interconnected, related to each other. So what other topics do you've got? You've got equilibria, chemical equilibria or chemical equilibrium. You've got the pure table. Now these are relatively easy topics. The ones that are not underlined are relatively easy topics. You've got air and water or environment. And finally, you've got organic chemistry, which some people find hard or difficult, but it's, especially in iGCSE, it's not that difficult. This is also, it happens to be relatively easy. Okay, the middle part is the place where, and especially in the middle part, if you get this right, if you know how to make formulas, how to make formulas of compounds, equations, balancing equations, and stuff related to acid, bases, and salts, 50% of your chemistry would now automatically become very, very easy because that's where everyone struggles. Okay. The top is easy, the bottom part is easy, this middle part is slightly. That is what makes things tough. Now, another reason what makes chemistry tough is that it's about past papers. Solving past papers specifically for chemistry is difficult. And there's a reason for that. So solving past year papers for chem is difficult. And it's not difficult per se. It's there's a reason for that. The reason is that all chemistry questions are interconnected, which means that if you get a question on metals, right? The question would not just be on metals. Some part of the question would be on equilibria. Some part might be on the periodic table. There might be stuff that would be related to chemical bonding. So the problem with the past year questions is that they are normally they don't stick to one topic. ठीक है, सर physics है ना, in physics if you have a question on gravity, you don't get a part which is on electricity. So if there's a question on kinematics, it's not going to involve momentum or anything else. So in most other subjects, questions they stick to one topic. But in chemistry, the problem is that everything happens to be interlinked. The metal topic is interlinked with electrolysis, which is interlinked with formulas and compounds and equations. They might give you a moles question in the middle. So the questions are kind of really messed up because they kind of jump between topics. So unless you have studied all of it, it kind of becomes harder to do past year questions because you'll get stuck. The question might be on chemical bonding, but there might be a tiny part on electrolysis. So if you haven't done electrolysis, you'll be stuck on that question. So which is why unless you've studied all of chemistry, it's normally difficult or challenging to actually do past paper questions directly. Okay? Is this clear? Then Malaika, Manu, is this clear?
Yes, sir.
Okay, so I'm just going to start with the first topic, which is kinetic particle theory. And remember, in this session, we'll focus a lot on, I mean, basically have to prepare for an exam. So everything would be focused towards solving exam questions at the end. So we're going to start with kinetic particle theory, which is something very basic, but there's a catch to it, which is, hey, although it's something extremely basic, but remember in chemistry, you have to, when answering questions, and let me write this down as well, especially related to past year questions. So when you're answering questions, remember this is not going to be an English exam or an Islamiyat or a Park Studies exam. It's a science exam, and a science exam demands that you answer the question in a particular way, which is the scientific way of answering questions. So you can't just go on writing stories. You have to be to the point. You have to be brief. You have to use certain key points. So it demands scientific explanations. It demands certain key points that need to be in your answer, or keywords, you can say that. They have to be in the answer, and they have to be brief and to the point. You just can't go on writing stories. If there's a definition that they're asking, it has to be the right definition. It has to be written in a certain way. If it's an explanation that they are demanding, the explanation should not be a story. It's not going to be a story like Baksis or Islamia. It has to be given in a very, very specific way. So the point with kinetic particle theory is that even though people find it very easy, the trouble is that it's very hard or difficult for them to actually answer questions or express themselves in the right words. Even in the simplest, and most people lose marks in the easiest chapters because these are the ones that they have studied the least and where they struggle with writing the answers, not with understanding the concept because it's an easy concept, but writing the answer. So I'm going to briefly first tell you about solids, liquids, and gases, which you probably already know. The solids, liquid, and gases, the first thing is you've got, I mean, these ones are going to be tightly packed, right? Let's go banal it takes again. So the first one, that's solid, that's slightly packed. The same one, if you turn it into a liquid, the particles are going to be more energetic. And if they're more energetic, they will be loosely packed. And they're going to be tiny gaps in between. Okay, so you can And the particles would be sliding past each other. They'll be moving around, so they'll not be stationary. Okay, so they'll be slipping and sliding past each other. And the last one, that's obviously gases. And in gases, the particles are going to be very far apart. ऐसे लेकिन ये सारे words जो है ना, we're going to write all those words down. They'll be, so they'll obviously not be joined with each other. And they'll be whizzing around very, very quickly in all sorts of direction. Okay, at great speeds. Achha, so that's what a gas would look like. So I'm going to start using describing. So this one is going to be called, what is the scientific term of describing this? That's known as a lattice arrangement, or the correct word is lattice arrangement. Whether you call it a regular arrangement of particles, and the other name for this is that it's a lattice. A regular lattice or just a lattice. You later on we'll talk about ionic lattices and metallic lattices. So it's a regular arrangement of particles. The other one, you can remember the keywords are very important. The next one is an irregular arrangement. That is not a lattice arrangement. Your last one is also irregular arrangement. Now, the distance between particles, this one is tightly packed. The next one is loosely packed. And the last one is they've got large distances between particles. Okay, so very far away from each other. Okay, so particles are very far away from each other. And so the third thing is about forces of attraction. Because solids are tightly packed, they're going to have strong forces of attraction. And these ones are going to have, the last one is going to have very weak forces of attraction, which is why the particles are like really far away from each other. So these forces of attraction are sometimes known as intermolecular forces, but that is not the correct terminology here until you know that it's a molecule, because we're not sure. We just generally talk about it. So at the moment, we're not really sure whether they are molecules or not. So beach wala jo hai na, that's they've got moderate. I mean, the particles are sticking around, but they're just slipping and sliding past each other. So the forces of attraction are strong, but they're not very strong. अच्छा और क्या है इसमें? You've got what else? Uh, the other things are about compressibility. Solids are not compressible. You can't apply a force because there are no gaps. You can't push the particles closer to each other, so they're not compressible. Even liquids are mostly not compressible. Or you can say, because they do have slight gaps between them, but they're not that many. So you can say very, very slightly compressible. And the last one is that it's very compressible because I said they're very compressible. Why? Because they've got huge gaps between them, as we discussed above. Okay, so they are very compressible. I said the next one is a energy. In solids, the particles are not energetic at all. They're just sitting around. Okay. So what is the movement of particles? And I'm going to talk about the energy. So solids are not energetic, and in gases, the particles are very energetic. ठीक है और बीच में I'm just going to draw an arrow. Uh, the middle ones are in between. I said, what is the movement of particles? In solids, the particles they vibrate to and fro about the fixed position. Acha, so they just vibrate. They don't move around. They can only vibrate. In liquids, the particles can move around. So what they do is that they slip and slide past each other, but they don't move freely in all directions. So they are just you got the liquid water, the particles slipping and sliding past each other randomly. And the last one is that it's in gases, particles can move freely in all directions. And the movement is going to be random and fast. Bल्कि the liquid come next to each other. The movement of particles is random and slow. So it's random and slow. ठीक है? Is this clear? एक रह गया वैसे और. ये clear है Malaika? Balu, is this clear? Is this part clear? और अच्छा इसमें important ये कि it's not about being clear. I'm pretty sure that you already know this. What is more important over here is the right keywords and the right terms that should be used when you're eventually answering your questions. Achha, so there's one thing left, which is that solids particles have a fixed volume and a fixed shape. So liquids, the particles have fixed volume. A glass of water is always a glass of water. So they always have a fixed volume, but no fixed shape. And the last one is no fixed volume, no fixed shape. Gases, if you have a balloon, it can expand or contract, so no fixed volume or fixed shape. So those are all the properties of solids, liquids and gases. Or इसमें you've got the next thing is you have what is the next thing? Temperature. Remember, you're going to hear the term temperature. Temperature. What does it tell you? It tells you it tells you the average, or it's proportional to the average kinetic energy of the particle. So if the particles are very energetic and they're moving around, that means the temperature is going to be high, or it's going to be low if the kinetic energy is less. Since you've got all these states, solids, liquids, and gases, and particles can move from one state to the other state. Okay, so they can move from solid liquid to gas They can also move from gas to liquid. They can move back as well. से इधर गया उधर से इधर आ गए so ठीक है looks good now अच्छा anyway so solids can move from to they can turn into liquid state and that process is known as melting. The opposite process is known as freezing. I'm going to write plus C. When you're melting, they're actually gaining energy, plus C. And when you're freezing, the particles are they're actually losing energy. अच्छा इसी तरह liquids can turn into gases. That's called what? It's called condensation. Not condensation, it's called boiling. Or it's also known as evaporation as well. And when particles go from liquid state to gaseous state, that is also plus energy. Okay? And vice versa, your gases can turn back into liquid, and that's called condensation. And that's minus E. Okay, that's minus E. As solids can turn into gases as well, and that's known as sublimation. Okay, this is sublimation. Or maybe they're gaining energy. Some particles can actually sublimate. See, you've got examples of that. A lot of particles they exist in all three states, but some particles they just go from solid to gas directly. And from gas, they can actually go back to solids, and that's known as deposition or solidification, where they eventually lose energy. Okay, so you need to know when particles are losing energy, when they're gaining energy. That question is very often asked. And surprisingly, a lot of people actually get that wrong as well. Okay. इधर बल्कि मैं लिख देता हूँ कि solids are the ones that have low energy. Gases are the ones that have the most energy. And ये बीच वाले liquids are the ones that have moderate amounts of energy. So basically what's happening is इनके पास these ones they don't have any energy. ठीक है, they're not energetic, they're slightly energetic, so they start moving around slightly, just slip and slide. When they get a lot of energy, they start moving around freely in all directions. So you've got three types of states: solids, liquids, and gases. ठीक है, चलें ठीक है बानूर, Malaika, this was just a short demo. ठीक है, so we can continue tomorrow then. ठीक है, चलिए कोई क्वेश्चन नहीं है किसी का? चलिए ओके देन, टेक केयर, अल्लाह हाफिज.